Okay, so hello and welcome everyone. We are excited to have you here today with us as we dive into the challenges of securing your cloud application and how to tackle those challenges from code to cloud. Feel free to submit questions in the Q&A box, and we'll leave some time in the end to address the questions. My name is David Hendri. I'm the co-founder and CTO at Solvo. I have over 18 years of experience in software development, and I've been focused on the cloud security domain for the past 10 years. Joining me is another David. I'll let him introduce himself.
Yeah, I'm David Melamed. I'm the co-founder and the CTO at JIT. I have a PhD in bioinformatics and about 2 decades of experience in engineering and another decade into cybersecurity. Really excited to be here with you to talk about this important topic.
Cool. So go ahead.
Yeah, so let's talk a little bit about what we'll talk about today. So this is a quick agenda. First of all, before talking about the challenges of cloud native applications, we'll start a little bit with history. How did we get here? We'll talk about the software security in the old world. And then we'll talk about the definition of cloud native application, which also will help us define the kind of the controls that are required and the challenges that are required in order to secure it. Then we'll talk about the challenges themselves, and David will show you an example, a live demo of an exploit into a container. And then we'll talk about how do you overcome all these challenges, these modern challenges, and we'll close this session about talking about future trends and in particular the impact of Gen AI. David, go ahead and talk about.
A lot of great things to talk about. So let's start. So back then, software security was relatively simple. You had your standard three-tier application consisting of the presentation layer, the application layer, and the data layer. Security mainly consisted of placing your web server in the DMZ and configuring firewall rules to control traffic between these layers and preventing internal networks from being exposed from the public network or from the internet directly. Additionally, the web server was regularly patched to address known vulnerabilities. It's pretty straightforward and relatively simple compared to the modern environment, modern cloud environment that we see today.
Yeah, indeed, and I think that a lot of things have changed since that period. I think that we started by breaking monolith into multiple services, and so this is an example, like really a diagram of how a modern application architecture looks like, and basically how you start with the code and at the end being able to deploy your application in the cloud. So most of the applications today are composed of multiple services that are composed of code. This code at the end goes through the process of CI, continuous integration. And then this is the place where usually you build your service into an artifact, a container. The container will contain your application code plus additional libraries. From this container, the container at the end needs to be deployed to the cloud. This is where it will be hosted, and this is where it will run. So that's the process of CD, continuous deployment. And this container will be hosted in a particular environment in the cloud. This is here an example with AWS. And as you can see, this service actually depends on a couple of other components in this application. First of all, it relies on the infrastructure itself of the cloud. It also has some connection with the data of the application. So there's not only code, there's also data. And also you have third parties that are integrating and having access to this application. That's important when you're looking at the whole risk surface, attack surface of the application. You have a bunch of components here that are combined together to give you a lot of the risk you will need to take care of. Next slide. And like this is kind of the real world example of how an application would look like, a modern application would look like in AWS. And as you can see, like these are a combination of multiple services here. These are in boxes that are that have dotted lines. You have also some buckets for hosting the static assets. You have a couple of Lambda functions all around. That's for serverless. You have database like DynamoDB. This is an example really of more serverless applications, so really modern. But you can see like we're really far away from the type of application, the type of architecture that David showed before. So that's the intro. And David, now let's talk about the challenges.
Cool. So as you saw, today's cloud environment are much more dynamic and complex, consisting of a lot more different components, resources, and this presents a new challenges for software security. And here are some of the main challenges that we'll discuss today. The first one is visibility. Resource provisioning. So as I mentioned, a standard cloud environment can have thousands of resources. AWS alone has more than 250 services. It is extremely hard to keep track of different configuration. What cloud resources are in use? Do you use EKS or ECS for container orchestration? What services are being used? Do I use a specific service or a database engine? In what version, what runtimes? Access to sensitive data. Where is the sensitive data? Who can access the sensitive data? How exactly the access is possible? Is it a container attached to a role, a human user? What exactly the access route? Misconfigured or vulnerable resource. Do I have a misconfigured or vulnerable resource? What type of resource? What type of vulnerability? Is it critical? Third-party access. So third-party access is very common today, whether if it's your monitoring tool or your development tool. These tools ask for access to your environment. And sometimes this access might be too broad or can have a potential risk to the sensitive data. Another challenge is the prioritization. So we have an overwhelming amount of issues. So even if you have the visibility, you can't really go over the thousands or hundreds of thousands of misconfigurations or vulnerable assets. How do you handle? How do you organize it in a digestible way to allow understand the security posture, at what exactly needs to be done, at what urgency? We have limited time. In an ideal world, you have enough resources to solve everything, but in the real world, with limited time and personnel, you can't address everything at once. So you need to understand what you need to solve first. How do you know what is important or has a higher risk? And understanding the context. What is the context of the issue? You might have a vulnerability in a private resource that doesn't have any access to sensitive data, or as opposed to a public EC2 instance or a container that hosts a web server and has access to sensitive data. So you need to be able to connect the dots in order to understand where to focus.
Awesome. And a little bit tied to this notion of context, we'll talk about now the third challenge, which is false positives. As you mentioned, like developers don't have time to fix everything, and you need to prioritize. One of the reasons to prioritize is that there's a lot of false positives. Now, what type of false positives actually you can find in a modern cloud environment. So first of all, you need to think about the fact that all the security detection tool, whether they're running on code, they're running on your cloud environment, they're all working on silo. They don't have a context. So sometimes they're detecting something that is not a real issue, or definitely not a real risk. So this type of findings actually something that you need to be aware of, and you need to deal with it. And we'll give a few examples. So, for example, take a look at a finding that would say that you have some a SQL injection, for example, or something similar to that. But because the tool doesn't know that there's some countermeasure, like for example a WAF in the environment, then it's not a real risk for the environment, and so you don't have to really fix it. Actually, it's not something that is exploitable. The second type of false positive is actually a true positives, in terms of that looking at the tool actually finds something that is valuable, but in terms of business risk, it's not a business risk. For example, if you find some issues in the dev environment, you still need to fix it, but definitely not with the same urgency with something that is on production. The next type of false positive is actually the true positive in terms of the tool, again, but not exploitable. For example, a secret detection tool that would actually discover, I don't know, an API key or an AWS key pair, but actually it's already expired. So there's no risk here. There's nothing you need to fix. And sometimes, like, fixing secrets actually quite some work. So here it's important to know, and you can verify whether or not the secret is selective. And the last example is actually not so much of false positives, but something that you need also to be aware of is that if you're looking only at security issues in a silo, you may find some low severity issues. So you may think that it's not something you want to deal with, but actually taking a couple of them, a combination of a couple of them together, you have a toxic combinations. And so this is something that can be really serious, and you need to know to deal with it. So these are all examples of false positive or true positive, but without the context of the business, you don't know it's actually true false positives. That you need to deal with it, and that's why you need to have prioritization. And finally, why is it so important to actually deal with all the false positives? Well, it's very simple. Developers don't have a lot of time, so if there's a lot of false positives, they will actually lose the trust in the tools. And if developers lose the trust in the tools, at the end they won't fix everything, and so there will be a huge impact on security posture. So be aware about it, and make sure that you deal with your tools and your findings in a way that you won't lose the trust of the developers, now that you get a better security posture.
Cool. These are really great examples for false positives. So after we discuss the challenges, now I'm going to show you a live demo where I exploit a vulnerable container running as a ECS task orchestrated by ECS, which is the the proprietary container orchestrator of AWS. And I'll going to use the overly permissive role of this ECS task in order to gain access to sensitive data. So this diagram shows an architecture of an e-commerce site where we have a load balancer in order to expose the site. And the site is, as I mentioned, implemented as a container running as an ECS task. The role that is assigned to the ECS task has permissions to access an S3 bucket and a DynamoDB, or at least this was the intention, and we'll see what exactly, how exactly it is configured and how to exploit it. And just noting that the process of the exploitation was simplified for the sake of the demo. So let's start. Okay. So this is the I opened Postman, and this is a post request to add an item to, into the cart using this payload. So here I can send a request, and then I get a 200 OK, which means that the item was added to the cart. If I examine the response, I can see that the response contains a server header, which says that the server is Jetty, an old version of Jetty. So Jetty is a popular Java web server. And this can help me to understand that the infrastructure is based on Java. And this leads me to the exploit that I'm going to use, the infamous log4j vulnerability. So I'll show you a diagram of the exploit, and this is what we are going to do. So log4shell, this is the name of the vulnerability. It is a very critical vulnerability discovered about 3 years ago in a popular Java logging library called log4j. The vulnerability allows the attacker to perform arbitrary code execution, which is very bad. And because log4j is a very popular Java library, the vulnerability affected many applications around the world. So this is the process of the exploit. So as I mentioned, we have the web server, the e-commerce site, running as an ECS task. The attacker starts with sending this magic string. This is called JNDI lookup string. Originally, the purpose of this magic strings was to allow the developers to add additional details in their logs, so they are able to query external resources in order to add details, for example, about the user, the session, and so on. So we use this capability in order to instruct the web server to perform an LDAP query. This is eventually an LDAP query. So we'll instruct the web server to perform an LDAP query, but it won't be a regular LDAP query, but will target the web server into a malicious LDAP server that I prepared in advance. And this LDAP server will instruct the log4j library to download a Java class from a bucket that the attacker owns, and the Java class will access the ECS metadata endpoint. So the ECS metadata endpoint is the way that in AWS that resources gain access to AWS services. So the ECS metadata endpoint consists of the credentials that eventually allows the ECS task to perform actions against AWS services, the S3 buckets, the DynamoDB tables, and other services. So the malicious Java class will instruct the ECS task to collect the credentials and send these credentials to an external endpoint that the attacker has access to. So this is the entire process, and now we'll go step by step and perform this attack. So the first step is to inject the Jandy LDAP query. So you can see it here in the post request. It mimics the add item operation. But before I execute this request, I need to run the LDAP server, to prepare the LDAP server. So I launched a regular EC2 instance in my environment, in the attacker environment. And for the malicious LDAP server, I'll be using an open source. There is an open source that the purpose of this open source is to test your environment and for educational purposes. And this open source allows me to launch or to host an LDAP server that can exploit or inject the malicious Java class when an LDAP query is performed. So in order to run this malicious LDAP server, I need to execute this command. So this command runs the LDAP server, this open source, and it tells the LDAP server to serve this Java class as a result to the query. So I executed the command. Now I can see that the LDAP server is in listening mode. And I'll send the LDAP request. Let's see. It should, okay. So I got a result here that tells me that the LDAP server responded to an LDAP query and was targeting to the exploit class that I created. So if I'll recap up until now, what we did was we performed the Jandy injection. The web server was instructed to perform an LDAP query, and the malicious LDAP server targeted the web server to download the exploit class and execute the exploit class. Now I'll show you what is this, what the exploit class does. Okay, so this is the exploit class. Is a simple Java class. I won't go over each line, but in high level, all the what the exploit class does is just accessing the ECS metadata URL, download the credentials, and send the credentials to an attacker endpoint. So I'll have access to the credentials. The metadata URL is, as I mentioned, it's an internal AWS endpoint that allows AWS resources to have access to the credentials in order to perform actions on behalf of the assigned role. So basically, after we injected the exploit class and the exploit class was executed, now I should have the credentials in my ready for use in my attacker endpoint. So now I'll move into the endpoint. Yeah, this. No. So the attacker endpoint eventually end up here. Of course, I need to reload the page. Okay. And I got a message, and the message consists of this object, and this object is exactly the object that holds the AWS credentials. So I can see here the AWS key ID, the access key, and the token. These three parameters what allows me to perform actions on behalf of the web server. So let me now configure these parameters on my machine, and then I will be able to mimic the actions that are being performed by the web server. Okay, so for this, I'll be using the AWS CLI. So the first action or command I'm going to perform is this. This command shows me my identity. Just a second. Okay, let's try again. Okay. This is just a proof that it is a live demo. Okay. So here this command shows me the identity of the credentials that are being used. And as I can see, the credentials are an assumed role that belongs to the app orders application. So if I go back to the diagram, the application is actually using the app orders role in order to access the AWS resources. So up until now, it means that I have the ability to perform actions on behalf of this role. So now I can try to explore and see what this role, what actions can be performed by this role. So I can try and list DynamoDB tables and see tables in this account. I can try and scan one of the tables and see the items. For example, here is the customers table, and I can see details about the customers. I can try and list the buckets that exist in this account. And I can try and list items inside a specific account, a specific bucket. Moreover, I can try and list other roles that exist in the environment. And I can see there are other roles. I can try and see for a known high privilege roles like administrator, or maybe the organization is using Jenkins and has a Jenkins role, which is probably a high privilege role. And I can see that this environment indeed have a Jenkins role. And then the next step can be trying to elevate my permissions. I can try and spin new instances with the Jenkins role and try to do the same thing that the Java code did and send the credential using the metadata endpoint, and then elevate my permissions and become an admin. So, okay, so let's recap. So we started with a web server running an e-commerce site. We exploited a vulnerability in the code that allows us to run an arbitrary code. We executed a code to hijack the ECS task credentials, and we use these credentials to access sensitive data, and eventually we elevated our permissions and gained admin permissions on the account. So why was it possible? So first, we have a critical vulnerability in our code. The instance was publicly accessible via a load balancer. The instance had an overly permissive role, which allowed us to access resources that not directly related to the application or needed for the application to operate properly. And eventually, the overly permissive role allowed us to elevate our permission by spinning new resources with higher permissions. Okay, so what can we do to protect ourselves? So potentially, you should always patch high severity CVEs. For example, in AWS, you have a native solution called the AWS Inspector that detects CVEs. You should use anomaly and threat detection. Again, in the AWS world, you have guard duty that detect anomalies. And you should maintain least privilege policies. You should make sure that the permission for each resource in your environment are the minimal permissions required for the resource to operate or to perform the job. And I assume that many of you think, okay, so how do I do it in scale? As we previously showed you that the modern cloud environments are very dynamic and complex. So the solution is combining visibility with the context, and that's enabling us to prioritize issues based on the impact on the environment and the risk to sensitive data. So for example, let's say you have two vulnerable instances. One is a business WordPress site with no access to other resources, and the other one is an e-commerce site with that has a misconfigured role that allows access to sensitive information. So knowing the context, you would probably start with the instance with the access to sensitive data and not the WordPress site. And now I'll show you how Solvo platform can prioritize and remediate issues based on the impact on the environment. Okay. So this is the Solvo console. Solvo is a SaaS solution. You connect your environment by granting limited read permission, and from that point, Solvo starts to collect all the data and analyze the risks and the configurations. Here we are under the security posture, toxic combos, and these are the connecting the dot that I mentioned. Here we take different risks, combine them together to understand what is the actual impact on the environment. For example, we have here a combination of a vulnerable resource that has access to read all the secrets in Secret Manager. And if I open the instance, I will be able to see the different core risks that together makes this issue has a greater impact. So this instance not only has a vulnerability, but also has access to sensitive data. So Solvo identified that there is a sensitive data, and this instance has a role with permissions to access the sensitive data. The instance is also directly exposed to the public network, and it uses an old version of the metadata endpoint, which is less secure. So the extraction or hijacking of the credential would be much easier for in this instance. So you can see here the vulnerabilities, the accessible, all the different data resources that can be accessed by this instance, with the specific resources that has sensitive data marked with this yellow sign. We have the visibility of the complete attack vector. So you can see here the instance in the middle and the network configuration, how exactly this instance is exposed, whether if it's a load balancer or directly by SSH, and combined with the permissions and the service accessibility. So you can see the role, which services are potentially can be accessed and which services actually being accessed. So you can see and understand exactly what is impacted by this instance. Eventually, in order to remediate the issue, you can click on the remediation button and then get a specific suggestion for the permissions, a least privilege policy suggestion. So you won't be able to spin new instances, assume another roles, list different tables or role or buckets. You will be able to specifically access the resources that needed to operate properly. Regarding the vulnerabilities, you can see the different CLI commands needed in order to update the vulnerable libraries. So this is how the process is done by using Solvo. Yeah, so back to you, David.
Yeah, that was a great demo. We're also kind of trying to tackle the same challenges using similar approach. As you said previously, like there's like you need visibility in order to understand what's going on. So at JIT, we are covering like the whole spectrum, the whole from code to cloud, the whole list of all the different domains, from the application code to the CI/CD, the pipeline, the artifact, the containers, the cloud infra, the runtime. These are all the domains that you want actually to have some visibility on, because as you said, as you showed an example, there can be some toxic combinations between different risks. And so by having this visibility across the whole SDLC, you're then in a better place to understand exactly the big picture. Now, having visibility is good, but the problem, as I said before, in terms of the challenges, is that usually all those tools have kind of working in a silo. And so what you need is to be able to connect the dots, like the same thing. And how do you connect the dots? So this is an example also of a graph, a little bit different than what you showed before. And here we're trying to connect basically from the code to the cloud to at the end to the customer. So it starts with the user and the team that is owning a repository. As you can see here, this in the example at the bottom, there's a finding there that is highly available, that is high severity, and also there's a fix available. And then by analyzing the repo and the CI/CD, we figure out a couple of things. First of all, there's database access. So it's a repo that is more sensitive because it's actually has access to customer data. And also there's a couple of lambdas that are deployed from this repo. One is to production. We have a tag of production. The other is actually externally exposed. It's internet facing through the API gateway. And so by taking all these different priority factors into account, you can prioritize. And I think that's the key. You really want to have the full visibility, to have all the information that you can in order to be able to decide what's important, what's not. And then you need the context in order to be able to connect the dots between all the different pieces of information that you have, whether they're coming directly from the tools, or they're coming from your environment, or they're actually provided by the user itself, in order to be able to get some big picture of your environment and of the risk of your environment. And from there, you should be able to have a clear understanding where you actually need to spend your time, and the things that really are matter in terms of risk for the business. Next slide. And so, for example, if you take all the vulnerabilities that you can get from all the different tools, like, across the whole SDLC, and you combine everything in terms of artifactor, you can get from like the 100% of all the vulnerabilities to only 3% that you really need to take care of, because these are the most critical, based on all the factors like the type of environment, whether it's dev or prod, the exploitability of the vulnerability, the criticality of the issue, whether or not there is a fix available. If there's no fix available, don't bother your developers; they won't be able to do a thing about it. So taking everything together, you actually can get to this only 3% of things you need to focus on. Right. So now we've been talking for almost an hour about all the challenges and then how you actually want to tackle the security of your modern stack. But what about new ways to actually tackle the problem? Because what we've shown until now are not really like super cutting edge novel techniques. These are techniques that are already exist for quite a while. And so is there another way, a new way, or revolutionized way to actually deal with that? And so, of course, we'll talk here about Gen AI. That's really been trending for a couple of, like at least a year and a half, if not more than that. And you can see that the ecosystem is actually trying to mature a little bit more. But what you can get in terms of benefits by leveraging Gen AI when you think about protecting your stack. So the first thing is that models are smarter and smarter. If you look at the newer model, the GPT-4 and the Claude 3.5, and you try to analyze your code, for example, you see that it's actually doing a pretty decent job, and can find sometimes things that even like the best SaaS tool, commercial tools cannot find. So the first thing is better accuracy in terms of detection, and things will only like get better with time. The second is the fact that we talked about reducing false positive thanks to rich context. And the thing is, when you have a big knowledge graph that is connecting all your dots, at the end, you still need to find ways to query the graph. And so right now, most of the companies and products are just writing a lot of queries by themselves, like manually in order to create a graph. But what if you can actually ask ChatGPT or any good model to actually query your graph? So that can be a second way to actually leverage AI. The third way is that, okay, what about getting rid of the vulnerabilities in the first place? So if now the code is generated by Copilot and all these LLMs, maybe you can actually get code that is generated is secure by design. And so you'll have actually less things to worry on. Even when you think about cloud and misconfiguration, if now you can have like your Terraform that is generated by AI, and you're actually very precise with what you're asking, you can also ask for a secure stack by default. So that's also super interesting. The next thing is about being able to test automatically. So, like all the security tests right now are still written in a manual way, because like all the tools that we know in DevSecOps are great for, searching for patterns, static analysis. But what about things that are really depending on your business logic? This is something that you will have a hard time to find tools that can detect, and you will need to write yourself like security tests. And so for that, you can also leverage Gen AI. And kind of the same way, if you're thinking about GRC, today is really a pain to do that manually. Gen AI can definitely help with that. And Gen AI Agent is kind of the newest version of it in an automated way. In an autonomous way, they can actually go and even detect everything and alert you about issues in your environment. The next thing is about policies. So policies is something that is really hard, because when you need to deal with that manually, like usually it's long text that are really hard to read, but that's actually a thing that Gen AI excels in, is actually understanding text and being able to summarize text and be able to understand if you're actually complying to a policy. So I think that think about a new way to look at policies that can be AI driven and can adapt to new threats in your environment. And finally, if you're thinking about agent can detect automatically, what about remediating in an automated way? So until now, we had things like Panda bot that can open a PR fix in an automated way, but that's really like some very basic trigger. What about some more intelligence in the way you actually want to remediate? Only remediate to things that you really need to, versus like open a PR fix for everything, for all the libraries you have in your environment. So that can be also something that we're all looking for. It's the kind of the future is how you can actually take your coffee and see all your agents working in your environment, delegating all the hard tasks, all the hard work that you have to do.
Sounds good. Cool.
Actually, David, you want to give some closing notes about this journey that we had for the last hour?
So maybe, but We'll start with Jessica. Do we have any questions from the audience?
Yeah, let's do question. We have 5 minutes for questions. That's great. You want to take the first question?
Go ahead.
I like to look where are the questions. Oh, in the chat, you have the questions. So there's a question about, do you have any recommendation for how to enforce organizational guardrails, such as enforcing specific versions of runtime or operating system, how to detect sensitive data, and who can access it? Do you want to take that?
Yeah, sure. So basically, you can start with the native tools. For example, AWS has a service called AWS Config, which mainly helps you with maintaining compliance framework, well-known compliance framework like PCI, HIPAA, SOC, and so on. But you have some kind of customization, flexibility for customization, but you will need to write and maintain your own code. In the Solvo world, we have our policy engine, compliance engine that analyzes or verify the environment against also well-known frameworks, but also custom guardrails. And you can do it by asking in a native language. We have a AI-powered assistant that can help you create and maintain guardrails. So that's it.
Awesome. Second question, the number of tools required to secure cloud-native application along the SDLC is kind of overwhelming. Do I need to learn all these tools? And the second question, developers are busy writing and deploying their code. How can we help them be more security aware and better collaborate with the security team? So regarding the first question, in terms of the number of tools, like that's kind of the challenge with DevSecOps, especially when you're looking at the whole SDLC. There's a lot of tools, and yes, that's a problem when you need to do everything manually. And that's kind of one of the reason we built into JIT this single experience for all those tools. So you have like maybe 20 tools, 30 tools, don't matter. Every tool's actually feel the same. Just to give you an example, like how it actually looks, you can see this is an example in a PR where you have like misconfiguration detection. You have some bucket in Terraform without any encryption. You can see like kind of the format of the review here. You have the findings and you have the security, the fix suggestion. But if I'm looking at another type, completely unrelated SCA, which is kind of looking at dependencies and vulnerability packages, you can see the same format, though is actually a completely different world. And if I'm looking at secrets, also kind of the same format. So all the vulnerabilities actually look the same, and so you don't need to learn all these different tools. You just need to actually enjoy one single experience. And regarding the second question with developers, how you can actually help them make more security aware and more keen to actually adopt those tools, I think that it's tied to the fact that you need to talk about security in kind of the same way you talk about quality. At the end, developers deal and care about quality of their code. And if they're looking at it in terms of you need to actually have a better quality in terms of code, I think that's a better way to deal with it. And so, for example, if you can have a portal like we do for them, so that they can really own the security posture of the services that they own, that they build, I think that's a great way to help them. First of all, have more visibility into the services that they own, and also help them with remediation, so that just like by click of a button, like here, they can remediate to those issues. I think our time is up, so I hope everyone enjoyed the ride. I know I did.
Me too. So thank you for the great questions. We hope today's session on cloud security and challenges and the future trend has been valuable for you. On behalf of both Davids, we appreciate your time. We look forward to connecting again soon. Stay secure.